So, welcome to the next lecture in electrical machines. We were discussing transformers, and in the first lecture of transformer, we have discussed the construction of the core as well as the importance of a transformer. So, we have discussed that transformer core can be made up of core type construction or cell type construction. In core type construction, the winding will be surrounding the core, so that we have discussed, and we have discussed that the low voltage winding will be close to the core and the high voltage winding will be away from the core, and between the low voltage winding and high voltage winding there will be insulation generally. But for the studying purpose, understanding purpose, we will be drawing the core in this rectangular fashion and showing the winding, that is the low voltage winding and high voltage winding, on the two different legs of the transformer. But in generally for the practical case it is not like that. Both low voltage winding and high voltage winding are on the same leg of the transformer. The other type of the core is basically the cell type transformer, where the iron is surrounding the winding. So we can have core type transformer or cell type transformer. Core type transformer winding is surrounding the core, and cell type transformer your iron is surrounding the winding. Generally, one more commonly used transformer is known as the Berry transformer, which consists of laminations arranged in group that radiate out from the center. However, all our discussions will be pertaining to the core type of construction because they are the one which is mostly in used. Now, transformer, as I said, can be of various sizes. So, for a very small transformer to a very large transformer, we will see some of the important features of this transformer first. So, when the transformer is small, the conductors are very thin and round. That can be easily wound on a former with rectangular or square cross-sectional area. So, if the transformer is small, the conductors will be thin and round, and it will be owned with a rectangular or square cross-sectional area. Whereas no special care needed for the construction of the core because the transformer is small, so special care do not require. However, in power transformer, so if you go for the power transformer, the transformer will be very big in nature, and the conductor size will also very big and increase. So flat conductors are preferred over the round one. So if you see in the small transformer, we are using a round conductor, whereas in the large transformer flat conductors are used. And winding for such conductor or rectangular former is difficult and introduce stresses at the bend of the conductor. So if the conductor is rectangular in shape, so when it is bending, maximum stress will produce in this particular area. So from the short circuit withstand capability point of view, also not desirable. So this rectangular cross sectional area is not desirable because there will be short circuit when the stress will be quite high. So for a given area, the length of the conductor becomes more, result in more load losses. So again, the length of the conductor is increasing and resulting in more losses. And to avoid the problem, the coils are made cylindrical in nature. So to avoid all these problems, whatever we have discussed, the coils, instead of making rectangular, we go for cylindrical coils. And core construction should be such that fill the circular space inside the coil with steel laminations. So the core will be filling all the laminations. So we'll see what is the laminations, and we know that laminations are done to reduce the eddy current losses in the core. And stepped core construction become mandatory in that case. So what is a stepped core, that we are going to see now. So here in this figure you can easily note how the stepped core are being made. So you can see that the core are not made like a rectangular fashion, but it is made in the form of stepped core. So cruciform core, these are known as, so these are made up of step core, and stepping can be of multiple fashion depending upon the requirement and depending upon the construction of the core. So there are different type of the cruciform core, what is known as the stepped core, and these designs are being mentioned here. So what is the percentage of the core cruciform or the stepping is being done, so that is being shown in the here. So these cores are basically laminated. So this laminated core is done so that the AD current loss is minimized. So we do not form a thick core, rather than laminated core is being made. Now we will go for the winding. So we have completed the core. Core can be two type. One is core type, another is cell type. So generally our discussion will be pertaining to the core type construction. Now let us see the winding. So what is a primary winding? So winding which is connected to the voltage source and creating a flux, that is known as the primary winding. So in case of a transformer, again and again we will be drawing this diagram. So this is the core of a transformer, and the winding to which the source is connected. So the winding to which the source is connected is known as the primary winding. And this winding is the one which is responsible for the production of the flux in the core. Secondary winding is the one which is induce the voltage by the principle of induction. So in other winding which is there, which is linking with the flux which is produced by the main winding or the primary winding, that is known as the secondary winding. So this secondary winding induced EMF is produced and it is connected with the load on the secondary side. So step down transformer, if the secondary voltage is less than that of the primary voltage, then it is known as step down transformer. Means if your primary voltage is Vp and secondary voltage is Vs, then depending upon which is more and which is less, you can decide whether the transformer is step up or step down. If Vp is less than Vs or Vs is more than, then it is a step up transformer. If Vp is more than Vs, then it is known as step down transformer. So whether the secondary voltage is more than the primary voltage or less than the primary voltage, decide whether you are stepping up the transformer or stepping down the transformer. Step down transformer can be made up of step up transformer by making the low voltage winding primary. So what is the mean? That these two windings are interchangeable. So instead of connecting the load this side, if you connect the load this side and source this side, then your step up transformer can become step down transformer, or step down transformer can become step up transformer. So by changing the position of the winding, you can easily change the nature of the transformer. Hence, it is appropriate to designate the winding as high voltage and low voltage winding. So we do not say a winding to be primary winding or secondary winding, rather than we designate the winding as low voltage winding and high voltage winding. So which side you can make it to be primary or secondary is a user's choice. However, the designation will be given in terms of low voltage winding and high voltage winding. So if I say that 110 by 220 kV, so the meaning is that 110 is the low voltage side and 220 is the high voltage side. Now it depends upon the user whether he wants to make this side as primary or this side as primary and takes the other side to be the secondary. The winding with more number of turns will be the high voltage winding. So obviously the turns will be a governing factor to decide whether it is a high voltage or the low voltage winding. So one winding which is having more number of turns, that is the high voltage winding, and one with low turn will be the low voltage winding. So the current on the high voltage side will be lower as VI product is a constant. So you know that power will remain constant in a transformer. So the product of voltage and current is constant. So basically if you change the voltage, similarly the current will also change to make the power constant. So on the high voltage side where the voltage is more, obviously the current will be less because it has to keep the power constant for a given VA rating of the machine. So any particular transformer will given a VA rating. What is the voltage ampere rating of the machine? Now the high voltage winding need to be insulated more to withstand the higher voltage across it. So if you have the high voltage winding and low voltage winding, the insulation requirement for the high voltage winding will be more because it has to withstand the higher voltage. High voltage winding also need more clearance to the core, yoke or the body. So clearance requirement as well as insulation requirement for the high voltage winding will be more because it is carrying more voltage. This aspect influence the type of the winding used for high voltage or low voltage winding. Since the insulation requirement is more, clearance is requirement is more, so a proper choice of the type of the winding become mandatory. Transformer coils can be broadly classified into concentric coils and sandwich coils. So when we have seen the winding of the transformer, it is basically either concentric or sandwich. So what is the difference between that two? Let us see. So in the concentric winding, that is the former, are very common with core type transformer. So when you have a core type transformer, you will be using the concentric winding, whereas if you have a sandwich coils, you will go with cell type transformer. So here you can see the figure of a concentric coil and sandwich coil. So concentric coils generally means that you will be having the low voltage winding and high voltage winding placed in such a manner that if you have this leg of the transformer, so on this winding first the low voltage winding will be there, so this is low voltage winding, and then the high voltage winding will come outside. So this is known as concentric winding, whereas the sandwich winding will be there when you have the low voltage winding and high voltage winding in the same core alternatively. So generally our discussion will be for the core type transformer and concentric coils. So this is what our discussion will be there for transformer, where we will focus the principle of the operation. So concentric arrangement, in view of the lower insulation and clearance requirement, low voltage winding is placed close to the core, which is at ground potential. So you understood that the concentric arrangement is going with the core type of transformer, and the clearance requirement is less, as well as the insulation requirement is also less. So generally the low voltage winding which is near the core of the transformer is at ground potential, so that is grounded. So you will be having the core and then the low voltage winding, so this is the low voltage winding which is present, so this will be grounded, and the high voltage winding will come outside. So this is the high voltage winding and this is the low voltage winding. So low voltage winding is generally in the concentric fashion, clearance requirement is less and insulation requirement is also less. High voltage winding is placed around the low voltage winding. So now high voltage winding will come from here and low voltage winding will be here. Tappings are provided on the high voltage winding. Now this is a good question which always like asked in the transformer, where is the tapping provided and why the tapping is provided? So tapping is provided because to change the transformation ratio or the turns ratio. Now what is that, we will discuss later. So if N1 and N2 are the number of turns in the primary winding and secondary winding, then depending upon the number of turns you can decide whether the winding you want to make high voltage or low voltage, or either step up transformer or step down transformer. Then this tapping which is given on the high voltage side generally takes the number of turns. So number of turns decide whether you want more voltage or less voltage. So tappings are provided on the high voltage winding of the transformer. It is not provided on the low voltage side. Low voltage winding is on the inner side of the transformer. High voltage winding is on the outer side, and you will be provided tapping on the high voltage side from the various turns. So the most common type of coils that are basically used are helical coil, crossover coil and disc coils that are shown in the figure. So here you can see the disc coils and helical coil in nature, how they will be owned. So generally for a power transformer, which is a very big transformer, we prefer to go with disc type of coils. So disc type of coils are basically of rectangular cross-sectional area where a particular disc, so this is one disc and there you have number of turns which are there, and then it is connected with the other disc. So generally the electrical diagram will be like this. So this will be one resistance, and then this will be one resistance, and current will flow in this manner. So current from the line end to the neutral end, the current will flow in the series with and disc to disc and turn to turn. So this is a disc, this is a disc, and this is a disc, and you have a different type of turns will form a disc. So generally in power transformer we'll go for the this type of winding, and in the crossover coils, if you can see that the crossover coils is going from here to here rather connecting from this side. So let us a little bit look into the more detail for the disc coils. So here in this diagram you can see a disc coils, and this is a power transformer winding, very commonly used power transformer winding. So in order to understand this diagram, let us first see here the construction. So the first turn, which is 1, then 2 and 3 and so on till it goes with 10, and then it is connected with the next turn 11. So this is your disc number 1, and then this is your disc number 2. Now where is the disc number 1? So these together becomes disc number 1, and again you will be having disc number 2, disc number 3, disc number 4 and so on. Now here if you see that 1 to 10 are the number of turns, and 1 is connected where the lead is connected to the supply, right? So your one turn will be this side, 1, 2, 3 and so on till it will come here 10. So this turn will go with 11. So this is 11 which is connected with 10 to 11. So these generally form a disc type of winding, and these are basically its turns, and the outer turn is connected with the other disc. So disc coils consist of flat conductors which is wound in the spiral form in the same place, spiraling outward. So that is a disc coils, and alternate discs are made at to spiral from outside toward the center. So alternate discs are there. So these two are discs are alternate here. Sectional disc or continuous disc may be used. Excellent thermal properties are there for this disc coil. Thermal property is very good, and behavior of the winding is highly predictable. So winding of a continuous disc winding needs specialized skill. This is the limitation. You technicians are required who are highly specialized to make this type of winding, and this type of coils are the one which is preferable for high voltage transformer that is used in the power transformer. Then you have a crossover coils. So it is made up of circular conductor not exceeding 5 to 6 square millimeter in cross sectional area. This is used for high voltage winding of relatively small transformer. So where the transformer is very small, however the voltage is very high, then you can go with crossover coils. Turns are wound in the several layers. Length and thickness of each block is made in line with cooling requirement. So this requirement, cooling requirement, we will discuss in the next topic. So that is very important in case of a transformer, because as the size of the transformer will increase, more and more loss will be there. So this I square R loss will result in the production of the heat. So this heat you have to remove with the help of cooling. So here a number of such blocks can be connected in series, leaving cooling duct in between the block as required by the total voltage requirement. So if you see and Google it more on the types of the winding, you can see the construction of that winding. And here in the crossover coils, the main point to be remembered is that it is generally used for small transformer of high voltage winding. Then you have the helical winding. So helical winding is made up of large cross sectional area, rectangular coil, and it is wound on the flat side. The coil will progress as a helix and commonly used for low voltage winding. So this is an important point to note down, that low voltage winding will be in the form of helix. So for a small transformer, both helical winding as well as spiral winding can be there. So low voltage winding you can make to be helical winding, and high voltage winding you can make to be spiral winding. So the insulation requirement also not too high, and layers no insulation is required. So they generally where insulation requirement is less, it will go with low voltage winding, because the low voltage winding is near to the core. So near to the core if it's there, then it has to bear the flux. So that is the reason low voltage winding clearance requirement is more important, and insulation requirement is more important. The complexity of the winding rapidly increases as the current to be handled is become more. Okay, so as the current requirement is increasing, current handling is increasing, complexity is increasing for this type of winding. the conductor cross section become too large and difficult to handle. So conductor cross sectional area will become large because more current it has to take and it will become more. The eddy current loss in the conductor rapidly increases. So again the eddy current loss will be there, and two or more conductors have to be owned and connected in parallel. So these basically different points are there which I will not read out more in detail for the helical winding, which you can just see whether what is the nature of the helical winding. So generally what I would like to say here is that for any transformer, generally when the transformer become big or power transformer, we go with continuous disc winding, and for a small transformer, low voltage winding and high voltage winding can be made up of different type of nature of the winding, whether it is a spiral winding or helical winding. And then the next nature of the coil that I have discussed is the sandwich coil. They permit easy control over the short circuit impedance of the transformer. So when you have the short circuit impedance, then what happens is that the sandwich coil is better compared to the concentric coils. And here high voltage and low voltage winding are close to each other, whereas you will not find in the concentric coils, and it has carried the same magnetic flux, leakage is reduced and mutual flux is increased. By increasing the number of sandwich coils, the reactance can be substantially reduced. So if you reduce the value of the reactance, obviously the impedance will reduce and more current will draw in the winding. So again, we have discussed the core and the winding. So we have discussed the core, winding nature. Now we will be requiring the insulation. So insulation requirement is very high because in the transformer, different parts of the transformer is carrying different nature of the voltage. So there are different type of insulation requirements. So multi-dielectric system generally plays a very important role in case of the transformer. So insulation is used in the electrical conductor in a transformer is varnish or enamel in generally dry type of transformer. So what is the meaning of dry type transformer? So in dry type of transformer there will be no oil. So what is oil? Oil is used in the transformer for the cooling purpose as well as dielectric purpose. But in the dry type of transformer, you will not have oil. So in such nature, you can use varnish or enamel as the insulation material. However, for a large transformer, the insulation requirement is increasing and cooling requirement is also increasing. So the tank is generally filled with transformer oil, which is the basically the mineral oil. So this mineral oil has two property. One is insulator and another is coolant. So either the oil will function as the insulation purpose and other will be having the cooling purpose. So here, instead of using the varnish and enamel, the conductor will be insulated with paper or cloth. Okay, and the whole winding will be dipped in the oil. So if you take this to be the outer core of the transformer and outer tank of the transformer, then along with the core, so this is the core and this is the winding which is there. So it is dipped in the oil. So this is your oil. So oil is dipped so that it provides us insulation and cooling, and the winding is having paper and cloth as the insulation. So what is happening generally? The porous insulation around the conductor So the porous insulation around the conductor helps the oil to reach the conductor surface and extract the heat. So whatever the heat is produced inside the transformer here, due to the presence of the oil, it will circulate in the winding and it will take away the heat of the transformer. So the conductor insulation may be called minor insulation or it can be a major insulation. So where the heat requirement is more, obviously it will have a minor insulation, and where the heat requirement is more, it is a major insulation. So major insulation is basically in between the winding. So if you have a high voltage winding and a low voltage winding, so between these, since the level of the voltage is changed, this is a major insulation. However, conductor insulation, the minor insulation is to withstand not too high. So where the voltage is less, you can go for minor insulation. And also you will provide ducts, oil ducts. So these oil ducts are used as between the insulation and the winding. So this generally is the feature of the insulation which is very important in transformer, and the oil plays a very important role for cooling and the insulation purpose. But you should understand that this oil should be free from moisture. So even a 1% moisture in the oil will degrade it. Okay, generally we call transformer oil as the blood of the transformer. So just in human, you test the blood to understand the functioning of the full human body. So similarly, if you test the transformer oil, you can say the nature how the transformer is functioning. So one main question is coming like, why larger unit size of the transformer are economically attractive? Generally, if you see that in a power transformer, it will be in MVA rating. Whereas if you go with a small transformer, it will be in volt ampere rating, and a medium size transformer will be in kVA rating. Why we economically it is attractive to go with larger size of the transformer, that is the MVA rating. So that we let us understand. So some points we'll discuss. So consider a transformer of certain rating designed with certain flux, density and current density. So any transformer will be designed for a particular amount of the flux that you know from the magnetic circuit point of view. Now, if now the linear dimensions are made larger, because when MVA rating is more, obviously the dimension will be large by a factor of K, keeping the current and flux density same. Now you are increasing the dimension but keeping the current and flux to be the same for a transformer. The core and conductor areas increases by a factor of K square. So once the dimension is increasing by K, the core and conductor will increase by a factor K square. So the losses in the machine, which is proportional to the volume of the material used, increase by a factor K cube, right? Dimension increase by K, conductor area increase by K square, and the losses increase by K cube. The rating of the machine increases by a factor K4. So the rating of the machine, which is MVA, kVA or volt ampere, this rating of the machine will increase by a factor of K4. So the surface area, however, increased by a factor K square, but the area is increasing K square, whereas the rating of the machine is increasing K4 and losses K cube. Thus the ratio of loss per surface area goes on increasing by a factor K. So if you find the ratio of loss per unit area, it is increasing by a factor K. The substantial increase in the output is the major attraction in growing for larger unit. So more and more larger unit, if you go, only K times you can see that there is a ratio of loss. However, one limitation is that cooling of the transformer become more and more difficult. So whereas the loss is considerably reduced when the rating of the machine is increased, the cooling requirement is basically becoming difficult. As the rating increase, better cooling techniques are needed for the transformer. That is the reason economically it is attractive to go with higher power rating of a transformer, but cooling will be a challenge. So there will be challenge for the cooling in nature. So there are different type of cooling aspects. So we have discussed core, we have discussed winding, we have discussed the nature of the oil and how greater the transformer rating of the transformer, better the transformer economically. However, we'll have some cooling aspect. So in order to cool the transformer, there are different methods are used. Like some of the methods are air natural, which is known as AN, air blast, oil natural, oil blast. So these are the different types of cooling. So if you are providing air only without flowing through the winding, then it is known as air natural winding. So this is the natural wire which is flowing through the winding to cool the transformer, similarly to a fan. If you are blasting the air from an external source, then it is known as air blast uh, cooling purpose. However, these cooling, air natural and air blast, will not work if the transformer is very big. In that case, irrespective of the transformer oil, you have to circulate the oil through the winding to cool the transformer. That is a very for a big transformer. So if naturally the oil is cooling, then it is a oil natural cooling. If you are moving the oil through an external source to take away the heat from the winding, then it is known as oil blast cooling. And there are again combination of oil and air. So there will be combination of oil plus air. So that will be known as oil forced natural or oil forced blast. Means combination of air and oil will be used for cooling the transformer. And this will help in sufficient amount of heat to be taken out from the transformer. Because in summer season, when a transformer operates, generally what happens is that due to the heat of the summer as well as the heat of the power loss, the transformer becomes quite heat. Then the temperature is controlled with the help of cooling of the transformer. So here in this figure, you can understand like how cooling is taking place. So if you see, there are some tubes which are connected in the transformer. So if you have a small transformer, then you will see that small tubes are there. If you have a very big transformer, then the tube size will increase. So what happened, there is a radiator and this is your main tank of the transformer where the winding is present and it is dipped in the oil. So due to the radiator, it is cooled and it is the air is circulated here, right? And then what happen is that for a big transformer you will be having an oil pump. So this oil pump, what it is doing is that it is taking the oil and circulating through the winding. So oil pump will be oil natural or oil blast. So this is basically a oil blast cooling. So instead of using a radiator, in combination we can use a oil pump to cool the transformer. Then again, with the help of oil, also you can have water cooling. Water cooling means the winding or the tubes have been thrown with the spray of the water over it. Okay, so this will be cooling through it. So you can have a combination of air, and basically the air as well as oil is generally used, and some cases where the heat is quite high, some air blown with water is generally used to cool the transformer. Now, as I said that transformer oil plays a very important role in insulation and cooling of the transformer, and there are some properties of the transformer that you need to know actually. So generally what happens is that the transformer oil is made up of mineral oil. So transformer oil is known as mineral oil. It is combination of carbon and hydrogen oil. Okay, and nowadays you can see that the vegetable oils are the good insulators and alternative, because lot of pollution is being created with the help of carbon and hydrogen, right, combination. So in order to understand the health of a transformer, generally what we have is that we test the transformer oil. So different tests are being done, like we test the viscosity of the transformer, we test the purity of the transformer, insulating property of the transformer we test with the help of BDV, that is known as breakdown voltage of the transformer. Okay, so different specific tests are there which are done periodically so that we can evaluate the nature of the operation of the transformer, whether it is in good condition or in bad condition. In generally, a transformer has a lifespan of 25 years. So 25 years is the general lifespan of a transformer. So generally, if you keep the transformer in good health condition by periodically testing the transformer oil and removing the acidic product. So generally what happens is that acidic byproducts are formed which are going in the transformer in the form of a sludge. Okay, so due to the heat of the transformer, there is a breakdown of the insulation which is there in the winding, and these insulation is going in the oil and deposit in the oil in the form of a sludge. So they has to be tested. So sludge formation, acidity, flash point and pour point are basically the temperature for which the transformer can sustain the heat. So these all tests are generally being done to evaluate the nature of the transformer and to keep the transformer in the healthy condition. Okay, so till here we have discussed the nature of the transformer, its operation, what is the constructional features, and in the next class onwards we will be discussing the ideal transformer and the operation of the transformer.